We are going to discuss in P block element is phosphorus. Phosphorus has two types: white phosphorus, red phosphorus. I will draw the structure of white phosphorus and red phosphorus. This is in 3D form. How it will get bond to each other is like this. This is how white phosphorus will be bonded, but whereas in red phosphorus, this is there is no a bonding is missing in red phosphorus. So that's the difference between red and white phosphorus. So this is all basic of phosphorus. Now we will go inside the properties of phosphorus, how it is going to affect the physical and chemical properties of phosphorus. So how we are going to what are the physical properties? What happens when phosphorus reacts with oxygen? It will produce phosphorus trioxide. If you add more oxygen, if you put more oxygen, for example phosphorus with more oxygen, you will get phosphorus pentaoxide, phosphorus trioxide, phosphorus pentoxide is produced. So what happens when phosphorus is mixed with chlorine? When phosphorus is mixed with chlorine, we will get 4PCl3. That is phosphorus trichloride, and with more chlorine we will get PCl5. That is phosphorus pentachloride. So what happens when phosphorus is mixed with NaOH, that is sodium hydroxide, with hydrolysis? The phosphine gas is produced. So this is how phosphine will form. Then you can add phosphorus will react with sodium, magnesium, calcium, etc. to form the respective chlorine, sodium, respective metals and non-metals. So we are going to see how phosphine. Next element we are going to see is phosphine, pH3, phosphine. How it is useful, where it is useful, preparation of phosphine, etc. we are going to discuss. So phosphine, now we are going to play when, as I told before, when phosphorus react with NaOH plus water, the same reaction, this is the preparation of phosphine, the same reaction, the same output. So only one preparation we have: put phosphorus and sodium hydroxide and white phosphorus. We have to use only white phosphorus here. White phosphorus, sodium hydroxide and hydrolysis process will get sodium hypophosphate, and this is called sodium hypophosphate. And we'll get phosphine gas. We'll get phosphine gas. So this is phosphine preparation. What will happen? This is the main preparation, but we also have so many preparations of preparation. Like for example, if you put phosphonium iodide, that is PH4I, with sodium hydroxide, we will get phosphine. sodium iodide plus H2O. So pH3 is formed here. So these are some of the preparations. You can also refer further preparation if you want to know is given, but the most important is putting white phosphate sodium hydroxide to form sodium hypophosphate and phosphine. Next we are going to see physical. What happens when you eat phosphine? pH3 is already guessed. What happens when you eat phosphine? 370 Kelvin will get phosphorus and 6H2. So in case if you want to prepare phosphorus, you can decompose the phosphine. It will form phosphorus and hydrogen. What else? If you oxidizes phosphine, you'll get phosphorus pentoxide. The reactions are same. If you add less oxygen, you will get phosphorus trioxide. So these are all the things, basic nature you have to learn. And you can also add chlorine to phosphine to produce phosphorus pentachloride, PCl5 and HCl. So how the structure of phosphine actually looks like? This is the structure of phosphine. I'll draw here. When phosphorus is bond with one nitrogen, 2H, because it's pH3, so it will bond with 3 hydrogen and 2 electrons will be remain here, because the valence electrons for phosphorus is 5. 3 electrons will be bonded with hydrogen, 2 will be remaining. So this is the structure of phosphine. Where all this phosphine? Phosphine is actually a red smoke. Heavy red smoke, so it is used in ohm signal. So this is used in ohm signal. For what is ohm signal? Is that for ships, coming ships in what you call the phosphine will catches fire easily when you add acetylene or some burning gases to it. So it will be used to give signals for lost ship signal, like lighthouse, like our lighthouse helps. It will give it's used for such purpose. So that is all about phosphine. So now we will see PCl5 and PCl3, phosphorus trichloride and phosphorus pentachloride. PCl3 is phosphorus trichloride. How PCl3 is produced? PCl3 can be produced by the preparation of HPPO3, H3PO3 with chlorine. When you chlorinate phosphoric acid, this H3PO3 is phosphoric acid. So when you put phosphorus with chlorine, it will produce a hypochloric acid with chlorine. We will get phosphorus trichloride. And we also know PCl3 when added with excess chlorine, we can produce phosphorus pentachloride. And what else is there in penta? And the reverse process is one of the chemical properties of phosphorus trichloride when PCl5 decomposes to PCl3. So if you add oxygen to it, you will produce if you add water and oxygen to it, we can produce H3PO4 acid. So that is all. If you put metals to it, you will get the respective metal chlorides, etc. So these are for trichloride. For pentachloride is also the same almost. So for PCl5 also it is similar to PCl3 and nothing more is there. And these are some of the equations they are given. I already taught what are all phosphorus preparation method. So these are some of the methods we can produce from hypophosphorus acid, orthophosphorus acid, hypophosphoric acid, orthophosphoric acid, pyrophosphoric acid, etc. So that's all. Students, about phosphorus. Next element we are going to discuss is oxygen.